Hello and welcome to another episode of Everything Digital Health. Today I'm going to talk about SNOMED CT again. I recorded a video about 5 or 6 months ago about SCT, which is a small Rust-based local tool set for handling SNOMED CT, which I wrote in the early part of this year. And I did a kind of walkthrough back in April about that. But a lot has happened to SCT since then. I've added a lot of features based on what I needed, but also other tools that I saw that seemed to be quite good. And I thought, well, we can add those features as well. Trying to bring together everything into something that's free, open source, easily available, is tractable to think about, as in you can download it, you can see the files on your disk, and you can start to sort of reason about SNOMED and to sort of connect different bits of disparate functionality. So, searching SNOMED within an application is one functionality. A terminology server is also something you might use for similar types of work. Handling code lists, that's another piece of work. Semantically searching to try and find the right codes to put in a code list, that's another piece of work. And so I thought if I can sort of bring it together to be the kind of Swiss Army knife of SNOMED, then it would be helpful for people. So I'm going to do a quick update of some of the new features over a series of episodes. I'm going to try and keep the episodes nice and short. So first up, I'm going to cover some of the basics, and that's coming up right now. Okay, first up, let's start with the documentation. So I've written quite a nice collection of documentation for this tool, because tools without documentation are useless. That's actually one of the things that I've found very difficult about the SNOMED world, is that if you don't already work in a company that uses SNOMED, or a health economy like the NHS that uses SNOMED, and you don't have colleagues to explain it to you, it's quite a steep learning curve to just get started. And so one of the things I wanted to get right with SCT was to have really good documentation. So first of all, if you go to this web address, patcharanero.github.io/SCT, you will see the documentation. You can also get there from the GitHub repository. There's a link right there on the GitHub repository. All of this is open source, and of course, you can go and have a look at the code. The documentation starts off with, how do you install it? And there's actually a few different ways to install it. This is one of the first ways. But if you go to the walkthrough, getting started, you can see that we've got instructions here for installing it on Mac OS, Linux, Windows, using the Cargo package manager, which is part of Rust. You can get a disk image for Apple Silicon, for Intel, and you can get it on the Arch Linux AUR. You can download it via Homebrew. We have a Debian package, and we have a Fedora Red Hat package. On Windows, we've got .exe that you can download. You can use the IWR as well. If you want to use PowerShell installer, you can use Scoop. So you've got a whole load of different ways to install SCT and get it runnable on your machine. At the moment, these executables are not signed because you have to pay a fee to get a signature mechanism from Microsoft and from Apple, and I haven't done that yet, although I do plan to do it. So that will come soon. But I'm hoping that the fact that it's open source, if you want to audit the code, you could actually prove to yourself that there's nothing nefarious in there. I stand by it, that there's nothing nefarious in my code. And of course, you can get an agent to audit my code now if you really want to, and prove that there's nothing nasty in there. The best way to get it, if you're concerned about that kind of thing, is to build it from source, and then you actually know that what you're getting is definitely what I intended you to get. But all of this is built automatically through continuous integration in GitHub, so there's no real way to sort of inject anything nasty into there. Cargo install is what I tend to use, and I have it installed locally that way. If you have any problems installing SCT, then that is actually good feedback for me to hear. So you can either feedback to me on the Open Health Hub forum, which is where I've got a thread about SCT, or you could create an issue in the GitHub repo, and that will be, both of those will get back to me, and I can try and help either solve the problem for you, or maybe I need to actually improve the way that distribution happens so that you can get the code. Once you've got hold of a copy of SCT and it's installed in your system, I recommend that you work your way through the walkthrough, which will take you through some of the features and show you what SCT can do. And again, if any of that is confusing to you, then do let me know. Something else that people might find helpful is this SNOMED CT primer, which is under the reference section at the top, and just talks a little bit about SNOMED CT and walks you through the ideas of the concepts, descriptions, relationships, reference sets, the groupings of codes that we use, the expression constraint language, ECL, that's used to avoid having to have a kind of hard-coded list. It's more of a expression of, we want this list by meaning. All that kind of stuff is explained, and I've done a nice sort of separation of ideas for clinical readers and for developers to sort of help you understand from where you're coming from, because clinicians will have an idea of why they need to know this, and developers have a different prior understanding. And so actually just thinking about those things slightly differently, explaining them, I think that kind of helps. So particularly if you find the SNOMED CT primer useful and helpful, then please do share it with other people, because I think SNOMED is one of those things that certainly when I was learning it, the resources out there weren't that great, and I was finding myself kind of fearing it when I probably didn't need to, because now that I understand it a bit better, it's kind of more straightforward. Okay, let's go over to the terminal and let's start typing some commands. So first up, if we just type SCT-V, that'll get us the version. So it's SCT 0.23.2 that's installed on my machine. I do make a number of releases, usually at least one small release a week. There's lots of development happening and I'm constantly adding new features. So do make sure you get the latest version for the latest features. If we type SCT paths, that will show you what paths SCT will look at to try and find the information I have on this machine. So I've got data home, which is CT's standard home directory .local.share /local/share SCT. So those are the defaults. That's where we keep the config, which is in .config. These are kind of standards on Linux, which is my operating system, and it's similar on Mac OS in terms of that there are conventions. It may be different on different operating systems. Again, if I've got anything wrong, because I don't routinely test these things on Macs and Windows, then do let me know. The config file has some of the static configuration that SCT needs. At the moment, that's not many things, but it may increase in the future. And then the database it's found is in the present working directory, and so it will tend to use that by default. So there's a kind of hierarchy of databases that SCT will use when it's operating on your SNOMED, so that you can have multiple different releases and versions, and you can put them somewhere, kind of thing. And then this section is where TRUD will download stuff to. So there is an SCT TRUD tool, which we'll use shortly, and by default it will download things to here, and it tells us what we've got there. So let's try that. If I type SCT TRUD, and then if you install the completions, in fact, let's just show you that. So SCT completions install will write the completions that will allow sort of tab completions, and it makes it a little bit easier to navigate a command line tool. So I recommend you do that, because it means less having to remember things and type things. But then let's SCT TRUD, and then if I type, I've got some options I can check. I can download Let's just check whether there's a new release. So using the TRUD API, it's telling me that I am actually up to date. SNOMED CT Monolith Edition 42.4. So we're up to date. Now, I've already done a lot of the downstream building using that monolith artifact, but I'm going to walk through the process of doing that. I just realized I didn't fully show off what the TRUD command can do, so let's just finish off there. I can list the subscribed editions that I've got. So you need a TRUD account in the UK to be able to download SNOMED, and you need to subscribe to each edition that you're interested in, and it will show me what I'm subscribed to and what its item name is. And to some extent, SCT is kind of hard-coded. Certainly the TRUD tool is hard-coded to look for certain types of release. So if I'm not looking for the thing that you need, then I can add that to SCT if you want me to. It is also possible to use SCT to just ingest any SNOMED source, and I'll do that in a separate video. SCT TRUD download. It gives me some options here, and what I would suggest is, firstly, if you tell it to download the UK monolith edition, UK monolith and pipeline, that will do all of the things that you need. So it will download the zip from TRUD, unzip it, turn it into NDJSON, and then do the SQLite database. So you kind of gets you in one command from nothing to a full usable set of tools. It takes a little while, so I'm not going to do that in the video, but that's the command that you should run. If I hit that, it's in fact, in this case, it's already detected that I do already have this file, so it's now just going to do the things. You've seen all this already. So firstly, we're going to make our NDJSON. So if you miss anything out, it will tell you what's missing, hopefully. So what I needed to do there was tell it which RF2 file to use. So let's go to RF2 and then the path in. So it was local share SCT releases, and then pick the release I want, and it will just do it directly from the raw zip. I'm going to do this in real time. I'm not going to stop the video, just so that you can see how quickly this will process the RF2 SNOMED release into new line delimited JSON, so NDJSON. The NDJSON blob, as it were, is just a great big file that contains the entirety of the SNOMED CT release, but formatted into a way that makes it a lot easier for us to reason about and query. So a single concept has a single line in that NDJSON. It's done. Yeah, that didn't take all that long. Because a single concept is a single line, you can extract that line, you can drop it into a text editor, you can have a look at it. And so you're immediately much more able to play around with SNOMED than you were with, for example, the plain RF2 files. So next, if we want to do anything with that NDJSON blob, we can just open it in a text editor. And I think in the last video, I showed that you can absolutely open like over a gigabyte of new line delimited JSON in VS Code and it won't crash, which is incredible, but it just works because it's new line delimited. And so it's not trying to pass the entire string into the buffer. It can just load in the lines that it needs to load in. But actually you can scroll up and down, you can use free text searches and things like that in your text editor. So already that on its own is massive superpower. You can now do things with the entirety of SNOMED that you couldn't do before, because you can just load it into a normal text editor without like breaking it. There may be other ways of doing this, but I've not seen them. The tooling out there is not all that great. Next up, we need to turn it into a SQLite database, and that will allow us to do other operations on it. Principally, the straightforward lexical search. So let's do that. So I'm going to make a SQLite database. We have to tell it what NDJSON to use is going to be. And I created this in the last operation, so let's use that. Again, I'm going to let you see all this in real time, unless it takes ages. But it's interesting to just see how long it takes and maybe compare it to other tool systems where I've certainly used some other SNOMED tooling where the process of importing an RF2 release is half an hour or an hour, or much longer than this. And I'm doing all this on a moderately high spec laptop. It's a Lenovo 9i Pro with an i9 Intel processor, but it's not a it's not a data center PC. It's not some kind of monster. So you hear the fan is spinning up a little bit there because it's done some hard work, but that still only took about 30 seconds. Now we can do some actual searching. So if we do a lexical search for, we're now searching the whole of that SNOMED release. As you saw, that was a virtually instant search. It's using a SQLite database on disk, so it's pretty fast. You're interacting directly with that. By default, SCT will pull in the inactive ones, but it marks them very clearly as inactive because I think it's quite helpful to be able to see what's inactive and what's active. So what you can see is that although I've got a search, it isn't the best search in the world, really, because heart attack is actually in some of these terms, and that's why they're on top. Even though these are either inactive or they're not the preferred term. Generally, myocardial infarction is considered the correct term for this, and there is a synonym. So it's realized that there's a synonym and it's linked it there, but synonyms are lower down the kind of hierarchy of the search terms. So as ever with SNOMED, part of the power is actually giving clinicians the good tools to be able to search quickly through SNOMED and find the things they need, and where necessary to guide them towards the preferred terms or the things that your organization would rather they record for organizational reasons. So lexical search is only so good. And let's just show you SCT info. So it's going to ask which NDJSON do I want. So this is a kind of top level breakdown of that release. So it tells me what the file is. It's 1.3 gigs on disk. It's NDJSON. Some other details built by the version of SCT, how many concepts, and then a breakdown of the kind of top level hierarchy for you. So it's just useful if you've got several of these, or if you're tracking them, you can get this data. You can also, with almost every command in SCT, you can get it in other formats. So for example, you could say you want it in -- format JSON. So instead of this little tabular human-friendly version, you want something in JSON. Obviously that will, if I just hit enter here, you will get a big blob of JSON, which is not necessarily that easy to read, but you could then use something like JQ to pull out specific information you want to know. So let's say you only want to know the edition, release date, release ID, and what it was built by. You can pull out specifically those keys. So this is useful for if you're building like automated tooling or something like that, and you want to say, okay, use SCT in the command line to pull down the stuff from TRUD. I mean, there are many other ways of doing this, but this is sort of helping to make it easier. Tell me what the release date is. Maybe you want to show that in the graphical user interface of your application or something, what the latest TRUD that it's the latest SNOMED that it's using, for example. So these are all like the flexibility of having command line tools that are composable. And I think to finish with, let's just show you a single lookup of one SNOMED term. So in this case, I've gone for this one, and so you look it up by SCTID and it will tell you what it is. It's tagged, where it is in the hierarchy. In fact, the full hierarchy there will be shown. And if you explore the tools inside SCT, you can get much more information about it, much more detail, and sort of understand how it fits in to the rest of SNOMED's hierarchy. These are some of the synonyms we were talking about. It's also cross-mapped into an old terminology called Clinical Terms V3, and that was its code X200E in there. And that's something that I'm trying to build on so that you can use this tool to kind of map backwards and forwards to old and alternate types of terminology system to help make a sort of flexible tool set that allows us to kind of translate between these things. Of course, because it's a command line tool, it can be automated. So if you've got a whole load of things that are in another vocabulary, you can use this tool to translate them. So that's the kind of thing that I'm here to try and do. I'll do a series of videos going into more detail about how all this works, but that's a kind of taster, and that should get you started. As I say, all the links will be in the show notes, so to get you to the repositories. And if you have problems, if any of this is sort of too technical, I'm working all the time to try and make it easier. And there will be graphical user interfaces and native tools that will install on your machine and just give you a desktop app that does this. But it's important that we start with the command line tooling, because that's where all the basic features go. That's where all the kind of functionality lives. And of course, create those issues, share the project with colleagues if you found it useful, and feed back to me if you have any problems or ideas or features or anything like that. And I'll see you in the next one.